1. Question 15. It reads, given the set X, given X
Sir,
is the set, hello,
Michael, accept her. She's going to join.
my meeting is open for now. Let us just try this network. Okay, so X 0, 1, and then Y 0, 1, 2. A, check whether each of the following operations is a binary operation on X and Y. Which operations? Check plus, minus, multiplication, division. Check if these are binary operation on X and Y. So let's start with the plus. So let's start with plus on X. Plus on X. So we have, let's put 0, 1 here. Let's put 0, 1 here. And put plus. Okay, then, so we're using plus here. Okay, so 0 plus 0, we're now adding. These are normal operations. When they say plus, you add. So 0 plus 0, we get 0. 0 plus 1, we get 1. 1 plus 0, we get 1. 1 plus 1, we get 2. Plus on Y, we have 0, 1, 2, 0, 1, 2. So we put, then we come and comment. Then we put plus on Y. So we start again. 0 plus 0, we get 0. 0 plus 1, 1. 0 plus 2, 2. 1. 1 plus 1, we get 2. 1 plus 2, we get 3. We get 2. We get 3. We get 4. Okay. So now let's comment. Is plus a binary operation on X?
No, it's not.
No.
So plus is not binary on X. Why?
Because there's no
The
2
major
in there.
Sir, kindly repeat again. The network is breaking.
So okay, so I'm checking. So first, when forming the table, you're just adding the numbers. So you put the row where you are putting 0, 1, and then another column, and then you put a column 0, 1. Then each space is so that when you add, you have the entry in there. So like The first row we have plus 0, 1. The first column we have plus 0, 1. Then you start adding 0 plus 0, 0, 0 plus 1, 1, 1 plus 1, 2. So we're saying because of 2, because of this 2, so plus is not binary on X because 2 is not a member of X. Simple. We want whatever we do to these numbers using plus, we should be getting a number that is in X. But in this case, you add 1 plus 1, 1 is in X. 1 is in X. When you add the 2, you get 2. 2 is not in X. So then plus is not a binary operation on X. What about on Y?
Not.
Okay.
So plus is not binary on Y because 3 and 4
And
are not in Y. Okay, let's go to subtraction. Subtraction on X. Again, we form a table, so we have minus 0, 1, 0, 1. So 0 minus 0, we get 0. 0 minus 1, 0 minus 1, we get negative 1. So we put negative 1. 1 minus 0, we get 1. So we put 1. 1 minus 1, 1 minus 1, we get 0. So we put 0. It was almost binary on X, but it's not. So minus is not binary on X. Because negative 1 is not in X. Simple. A question now without a table is minus binary on Y.
no,
Is
it's
minus
not.
binary on Y. So minus is not binary on Y because 0 minus 2, you get negative 2. 0 minus 1, you get negative 1. These numbers are not in Y. Let's go to multiplication. Multiplication on X. So we'll have multiplication here, 0, 1, 0, 1. There we go. 0 times 0, we get 0. 0 times 1, you get 0. 1 times 0, you get 0. 1 times 1, you get 1. So multiplication is binary. Next. Because all our solutions are elements of X. Multiplication on Y, we'll have multiplication 0, 1, 2. 0, 1, 2. I don't need to do all of them. I'll just go to 2 times 2, which is 4. Then I'll say multiplication is not binary. And why? Since 4 is not in Y. Like that. So you need to just find one number that does not lie there. Then you know, oh, it's not binary. You can even validate your answer. Say, oh, it's not binary because of this. Division on X. You put division here. 0, 1, 0, 1, 0 over 0, and defined. 1 over 0, and defined. Immediately you get 1 and defined, we can conclude to say division is not binary on X and on Y. Because even on Y we have the same thing. 2 over 0 and defined. Now we should be able to say, okay, we understand the meaning of binary, of what it is to be binary. Then we go back to plus. Is plus commutative?
Yes, it is.
So plus is commutative. When you're adding 1 plus 1, you add 0 plus 1, you get 1. 1 plus 0, you get 1. So the operation does not need to be binary for it to be commutative. Like plus on Y. In fact, plus on X, we said it's not binary, but it is commutative operation. Plus on Y is commutative. Division is not commutative because 1 over 0 is undefined, but 0 over 1 is 0. So it's not commutative. Gives us two different solutions when we switch the order. If we say 0 star 1 means 0 over 1, then 1 star 0 will mean 1 over 0. Undefined, defined. What about associativity? In the case of plus, say 0 plus 1 plus 1. This will be the same as 0 plus 1 plus 1. Same thing. So plus and multiplication. These guys are binary. I mean, they are commutative and associative. But division, because of 0 there, it's not for both. Then minus is not. Because 0 minus 1, 0 minus 1 is negative 1. But this 1 minus 0 is 1. Different. Can't even try. The last question on this is question 16. Question 16 has got so many babies there. 1, 2, 3, 4, 5. Each of the following operations is a binary operation on the set of real numbers. No need to check. We've been told already. That's a binary operation on the set R. 1. A star B has been defined as A plus B multiplied by A minus B. For simplicity, you can expand this. Immediately you see it, you expand it. A squared minus AB plus AB minus B squared, which is A squared minus B squared. So we're talking of A star B as A squared minus B squared. A very simple thing, like this. Then A, is it commutative and or associative? So let's start with 1, commutativity. We want A star B to be equal to B star A. Is it the case? So we'll go to the right hand side because we read at the left hand side and pick B star A is B squared minus A squared. This is not equal to A squared minus B squared, which is equal to A star B, the left hand side. Star is not commutative. Subtraction, when you see subtraction, if first thing to think about is that it's not commutative. Because if I have 2 star 4, this will be 2 squared minus 4 squared. This is 4 minus 16, which is negative 12. If I have 4 star 2, this will be 4 squared minus 2 squared, which is 16 minus 4, which is positive 12. Positive 12 is not equal to negative 12. Come in. So there's that variation. So there's that variation there. Then is it associative? So you say, okay, to check associativity, we must check A star B star C if it is the same as A star B star C. Left hand side, A star B star C. This part is in the question, which is A squared minus B squared star C. So this now has become our new A. Just like this guy is our new A in our definition. This is our new B. So on the right, we must have A squared minus B squared. But what is A? A in black is A squared minus B squared. The whole thing should be squared minus C squared. Just you leave it there. Don't simplify it. Get the right hand side. You have A star B star C. This is A star. B star C is B squared minus C squared. Okay. Now, A squared minus B squared. Your A is 2A, so we have A squared minus B is now this whole thing. So we have B squared minus C squared cross square. At this moment, you can now start comparing. So you say,
Excuse me, sir.
okay.
Why are you square? Square.
So why are we squaring? Because the question says, A, if you have A star B, you square A, you square B, and then you subtract the two. That's how the star has been defined. So just squaring the placement that we are putting here. Then now we compare. Are they equal? You just go to C. For the top one, C is squared. The down one, C is to the power 4. When we are done expanding, we'll have C squared being multiplied by C squared at some point in the expansion, which will give us C to the power 4. So you say left hand side not equal to right hand side. Star is not associative. Okay, on the same, so let's do.
Sir,
Yes.
I can't understand. Why are you squaring this? I'm trying to get the concept.
We are told that A star B is A squared minus B squared. That's what the question is. This is the question. What we are given initially is A star B, which is equal to A plus B, A minus B. Then we expand it for easy simplification. You expand so it becomes easy for us to calculate. To expand, you get A squared minus AB plus AB minus B squared. This is giving us A squared minus B squared. This means that A star B is A squared minus B squared. This means that if you have 2 star 5 On the right, you have 2 squared minus 5 squared by definition. So whatever becomes your A, you square it. Whatever becomes your B, you square it and subtract. Then 3 of the same, which is B now. For each of the following operations, evaluate 3, find 3 star 7 star 4. This is where now maybe we understand it very well. So you start with the brackets first. You say, what is 7 star 4? 7 star 4 is going to be 7 squared minus 4 squared. Because 7 becomes A, 4 becomes B. So we have A squared minus B squared, giving us 49 minus 16, which is equal to 33. Do we now understand why they must be squared?
Yes, sir. Thank you.
Good. So when you pick one, you run through, you check if it's commutative, if it's associative, then you evaluate 3 star 3, 3 star 7 star 4. So this is 7 star 4. Then you go back and do 3 star 7 star 4 has been found to be 33. So this is our A, this is our B. So you have 3 squared minus 33 squared, which is 9 minus, what is 33 by 33? What is 33 by 33? One 1089, if my math is correct. So you get
Yes.
1080 negative. So you first get what is in the brackets, evaluate it, get a single number. That single number you get, put it now in the brackets. So you have 3 star 33. Then you rename your A, B. That's how you get the thing worked out. Okay, next, the second one, A star B is equal to AB. This one we have done such a similar question. So go to the third one. A star B, A star B is equal to 2A minus B. Is it commutative? Is A star B the same as B star A? So B star A is 2B minus A, but this guy is not equal to 2A minus B, which is A star B. So star is not commutative. So I said once we see a minus, if there is no square around that minus, then you say, okay, this is not it's not commutative. The only time minus will survive into commutativity is when you have something like this, where the minus is being neutralized by the square. If it is standing alone like a minus b as a power, because a minus b as a power is the same as 2 to the power a over 2 to the power b. But this is different from 2 to the power b over 2 to the power a. Is it associative? A star b star c. This is the same as 2 a minus b star c. So that now you start with 2, then your a is this whole thing. So the power becomes 2 a minus b, then minus c. Because this becomes your a now. So it's like you have your a, b. So you need 2, which is this 2, and then a minus b. This is the a, this is the b. Of course, when you arrange this, if you get a star b star c, you have a star 2 b minus c, giving you 2 a minus 2 b minus c. Not associative. Not associative. Compute 3 star 7 star 4. We'll start with 7 star 4. So 7 star 4 is equal to 2 a is 7 minus 4, giving us 2 to the power 3, which is 8. First thing. Then now we go back. This question is now the same as 3 star 8. So now what is 3 star 8? 3 star 8 is 2, 3 minus 8, which is 2 to the power negative 5, which is 1 over 32. As your final solution. Okay. So you've just remained with 2 to do. So you do 2. So you do the fourth one. A star b is a plus 2b. And the last one, a star b is a plus b minus ab. So let's start posting the solutions at this is 1934. So at 1945, let's have the solutions in the group up to if things are so difficult for you, at least post 3 star 7 star 4 of each part. Up to 10 hours, we'll close the discussion of these questions.
Center, sir. You said which questions are we doing?
The remaining ones on 16.
On 16.